Hey, so we're going to start this video about precipitation reactions with a very unfun and unpleasant thought, and that is kidney stones. So, if you don't know what a kidney stone is, you're doing well. But if you've had a kidney stone, that probably might be the most painful experience you've had in your life. And if you haven't had a kidney stone and you know someone who does or has had one, I'm sure you could ask them about it, and they will greatly tell you all of the painful experiences that they have. But kidney stones are things that they are these solid objects that can form in your kidneys, in your urethra, and they can really block your passages for urine and can cause extreme amounts of pain, swelling, burning. And it's very difficult to use the bathroom. Okay, and so kidney stones can be a result of a few things. There's a genetic component, but also it can be from a lack of proper healthy diets, and it might be that you're not drinking enough water, and you might have a diet that's too high in protein and sugar. And there are some ideas out there that maybe drinking too much milk and not enough water can develop kidney stones. So just be careful. But anyway, as we can see here, kidney stones, they can form and they can block those ureter passageways that would block urine, and that will damage your kidneys. So they're extremely painful to pass. You might say that you have to pass a kidney stone. Sometimes if they're too large, you have to use surgery. But the reason I bring up kidney stones, not that I want to, but the reason I bring them up is that they are actually an example of a precipitate. And a precipitation reaction is when we have a reaction that we can see here. We start with calcium chloride and we have sodium oxalate. We combine these things, and then what we get is this thing called solid calcium oxalate, which, if we look at our state of matter, is a solid. And that will be pretty strange looking at it in real time, because we started with two aqueous solutions, right? Two things that dissolved in water. So we actually wouldn't even be able to really see these molecules until we put them together, and then all of a sudden, boom, kidney stone. Very sad, very painful. Okay, so a precipitate is the solid insoluble mass, meaning it can't dissolve in water. And it can form when two aqueous solutions are mixed together. And in order to determine what the precipitate that forms is, you must refer to a solubility table. We have two solubility tables in this handout. Yay. So we'll take a look at both of them later on. But say we have another solution. In this case, we have silver nitrate, and we combine it with potassium chromate. Again, we both notice they are aqueous solutions, right? So two liquids. We can't see these ions actually with the naked eye. But we have these ions floating around in the solution. And when we mix them together, what do we see happen? Well, chromate ions, or CrO4, is actually going to form a solid with silver, or Ag here. So those ions are going to form our insoluble precipitate. And if we were looking at this, it would just kind of look like a rock, some type of solid at the bottom of the container, when before there existed none. Okay, so precipitates form from generally metals like silver, ammonium, barium, calcium. So our solubility tables will kind of help us determine when a precipitate will form. Okay, so now we get to this part. So, important part here, most precipitation reactions are single replacement reactions or double replacement reactions. We've talked about these before, and once we know what the type of reaction is, say it's a double replacement, we're able to predict the products. So a lot of the handout or questions for this handout is to predict the products. So we're going to use these, we're going to run through these as an example, but we also want to make sure we write the state of matter next to each solution. And that will help us because we are also going to be looking at this table to determine if a solid formed, and that's going to be our precipitate. Before I go on, sometimes too, if we go back up, to this solution. So say we look at, notice how we had silver and chromate form a precipitate. What happens to nitrate and potassium? Well, those things just kind of, they stay in ions, they're ions in the solution. In the final solution, they're still ions. And we actually call that, these are called spectator ions, right? Because they're not involved in the actual reaction. They do form potassium nitrate, but it's basically when an ion does not form a precipitate. Fancy way of saying solid in a reaction. Okay, so spectator ions, they just kind of stay in the solution. All right, so to predict the products, these are all double replacement reactions, right? So remember our double replacement kind of template. AB plus CD, what happens? The C and A, they do a little dance and replace each other. So AD plus CB. Our cations are replacing each other. All right, so our first one, we have silver nitrate plus potassium chloride. So first we have silver chloride plus potassium nitrate. Okay, so now we need to look at our solubility table and determine if they're aqueous or if they are a solid, if a precipitate has formed. So first, silver chloride, let's start with that one. So if we look here, we're looking for silver. There it is. And then on the top, we want to look for chloride, which is right here. And what we can see, basically follow the line down. We can see, look at that. That is a solid, right? So that means this is going to be our precipitate. And then if we do this again with potassium nitrate, we can find potassium, there it is, and find nitrate. There that is. So we go down and down. That would be that one. So that's aqueous. That means those ions, that means it's dissociating and forms ions in the solutions. All right, let's keep going. All right, so first we have iron nitrate plus sodium hydroxide. So this is another double replacement. So iron hydroxide plus sodium nitrate. All right, let's mix up the highlighting. So iron hydroxide first, all right. So real quick, we see iron 2 and iron 3. How do we know which one to use? Remember, the Roman numerals stand for the charge of the iron cation. So hydroxide, which has a -1 charge, and there's 3 of them, has a total of a -3 charge. Iron and ionic compounds have to cancel out. So that means this iron has to be +3. Okay, so that means that we are going to be using iron 3 as our cation. And then we're looking for hydroxide, which is right here. And go down, move it that way, and here we can see that this is our precipitate. All right, we got a solid that formed. All right, next one, we have sodium hydroxide. So sodium, is, oh, it's off of the list. Shoot, but what we can see is sodium hydroxide, and that's going to be aqueous. Sorry about that, must have got cropped out. All right, so our next one is aluminum sulfate plus barium chloride. So another double replacement. All right, so aluminum chloride. So here's aluminum, Here's chloride, and we don't even need to really go on from there. That's aqueous, right? We found chloride there. There's aluminum. Okay. Next is barium, which is right there. So barium sulfate. Sulfate is, there it is. And we go down, this goes over, and there is our precipitate. Okay, so next one, hydroiodide. All right, so find hydrogen. Let's see. Oh, sorry, we gotta write the actual products first. So in this case, we have zinc iodide plus hydronitrate. All right, so whenever we're dealing with something with hydrogen in it, that's going to be our aqueous solution. All right, so hydrogen, that's just going to be automatically aqueous. For zinc iodide, we got to look at the table here. Oh, and that one also got cut off, unfortunately. But if we scroll down, or if we use iodide and zinc, we'd actually see that that is our solid. Or, sorry, excuse me, that's actually a precipitate. So what that means is that we have no precipitate in this one. All right, so two more. So next we have calcium chloride plus sodium perchlorate. So this is going to be Ca3PO4 plus sodium chloride. All right, so our calcium phosphate, we'll find that. There's calcium. And there's phosphate. And we can see that that is a solid. Oops. That's our solid. Sodium, again, it got cut off. Sorry about that. But this is aqueous. All right, last one. Lead nitrate plus potassium sulfate. So this gets us lead sulfate plus potassium nitrate. All right, so find lead. Okay, there's lead, and then sulfate. It's right here. And we can see that is a solid. And then the last one, potassium nitrate. There's potassium, there's nitrate, and that's aqueous. All right, so that's how you can predict the products. Again, you got to use a table in order to do that. Also, based off our review of double replacement reactions. This is another solubility table, so we can use this for some problems as well. And basically, we have our cations on the y-axis and our anions, our negatively charged ions, as the x-axis. And whenever we say something like lithium and we combine it with nitrate, we can see that does form a solubility, or soluble. Okay, so what that means is basically we can use this to determine if it's going to form a precipitate or not. So S stands for soluble, and then N means insoluble, which means precipitate or solid will form. Okay, and then we also want to think about one last thing here is water. So can we determine if something will form a precipitate in water? So what happens is, let's say we have something like magnesium chloride plus H2O. We put that in water. Will that form a precipitate? So anytime you're using water, we're actually using a hydroxide ion. So this is going to be magnesium hydroxide. And then we have hydrochloric acid, right? Because the hydrogens and the chlorines, they're going to work together. So then we can go back to this table, or we could also use this one. We have magnesium, and then we have it bonding with hydroxide. So that N means that it's insoluble. Okay? So once that happens, once we know that it's insoluble, we'll say that's actually going to be a solid. All right, so the question's kind of based off of that. Let me know if you have any questions.